Hello everyone. Hi, my name is Antoinette C. Pahanoy of BS ECE 3A, and today I'm going to discuss to you all about T flip-flop. Starts with the definition of T flip-flop. So T flip-flop is a flip-flop that toggles the present state of the output. Next, let me show to you the logic symbol, which I created two, which is for both sides, positive and negative. So where the T represent as a toggle or trigger input, CLK is the clock, Q is the output, and Q bar is the inverted output. Where why there's two differences here, because a T flip-flop is an edge triggering device. Edge triggering means a flip-flop always responds to transitions of a clock pulse. So first table or symbol here is a positive pulse edge triggering, which only responds from a low to high transition of the clock pulse. Second here is a negative pulse edge triggering, which is only response from a high to low transition of the clock pulse, which is represented by the small circle here. And the other positive pulse edge triggering is represented by a small triangle here. Next, let me show to you a circuit diagrams, which are created from three different flip-flop as well, where considering that the simplest of the constructions of a T flip-flop is with the JK flip-flop, which is showing in this first one here. Because the J input and the K input of the JK flip-flop connected together and provided with a T input, as what you have shown here. Next is from the SR latch or SR flip-flop, where the output is getting a feedback behind the R, and the inverted output is getting a feedback behind the S, where the AND gate for R and S is connected to T or toggle input, which we also call as an input terminal. Next, from the D latch or D flip-flop, where the feedback is from the output to the XOR gate, which is connected to the toggle input or the input terminal. Alright, next will be the truth table. So here's the truth table, where the truth table determines the next output depends on its input, of course. And considering that if the T, which represents the toggle or CLK for clock, and the Q will be the output, regardless if the T is 1 or 0, but there's no clock pulse, so the output is in hold state. Next, if the toggle input is 0 or in low, and there's a clock pulse, still it's on hold state. But if the toggle input is in high and there's a clock pulse, so the output will toggle. Next is the characteristic table, which is coming from the truth table. Moving forward, T will represent for toggle, Q will be the present output, Q next is the final output. If the toggle and the present output is low or 0, so the final output is still low or 0. Next, if T is 0 and the QN or the present output is 1, so the final output is 1 or in high, and T is in high or 1, the present output is 0 or low, so the Q or the final output is 1. And if the T is in high and the present output is in high as well, but the final output will be 0 or low. Next is the excitation table. So for the excitation table, it comes from the characteristic table. As what you have seen here, if the T is 0 here, the Q or the final output and the present output is still 0. Next is the T is 1 or in high, which is this. So the QN or the present and the final output is 0, 1. which is this one here. And next for the T, which is 1, so the final output is 0 and the present output is 1, which is also showing here. And next, if the table for the T or toggle input is 0, so the both Qn or Qnext or the present and final output is 1 or in high. Okay. I'm going to show to you a simulation using electronic workbench to simulate T flip-flop, where this T flip-flop is created from a master-slave flip-flop with two asynchronous active low inputs. So the preset here make our output high, as well as with a clear here make our inverted output high. And you can see or notice that the two outputs is toggling simultaneously. So let me show you an example showing T flip-flop being initialized. So first we need to make one output to be high, and for example, the Q here, and we'll make the preset turned off. So you can see that the Q is on high now. Next, we're going to turn on the toggle, and we are going to toggle the clock pulse, and then we are going to turn on the preset. And now let's try to toggle the clock pulse again, where you can see every time the clock pulse is going into low, the outputs is toggling. Now, let me demonstrate an example or where showing the function of the T flip-flop, where when the toggle input is low, so there's no changes at all, which is exactly what is happening here. But when the clock goes low and the toggle input is high, every time the clock goes low here, the output will toggle every time. That's what you can see here. Okay, I guess that's it for this video, and I hope you've learned something from me, and see you on the next video. Thank you for watching, and goodbye.